In this session, we'll expand on our earlier discussions of model fit and measurement reliability. Specifically, in the following tutorial, we will deal with other forms of measure validity and some advanced topics on model refinement. We will begin by looking at different facets of construct validity. As you recall, thus far we have considered three indicators of measure reliability: Cronbach alpha, average variance extracted, and construct reliability. These indicators all addressed inter-item reliability and show whether respondents are consistent in their ratings of similar items. Although such tests are necessary, they are not sufficient to address validity of your measures, the question whether you are actually measuring the constructs of interest. As you recall, construct validity is the extent to which a set of items reflect theoretical latent construct they are designed to measure. There are several aspects of construct validity, including phase validity, nomenological validity, convergent validity, and discriminant validity. The first two aspects of validity rely largely on researchers' judgment, whereas the last two can be empirically tested in AMOS. I will go through them one by one. Phase validity concerns the extent to which the content of the items is consistent with the definition of your construct. There is no empirical test for phase validity, and the evidence of phase validity stems from your definition of constructs and their related items. To demonstrate phase validity, you should provide a detailed definition of each of your construct, name the source of this definition, and list all the items which correspond to the construct. To further convince the readers, you may refer to existing literature, pre-study finding, or any exploratory work such as interviews with experts. Essentially, phase validity of the construct is established prior to SEM analysis. Nomenological validity is assessed by examining whether correlations between the constructs in the measurement model make sense, whether they fit the theory. For example, in our Bagotzi's model, we would expect all correlations to be positive because the theory suggests that the latent constructs influence one another in that way. Because your research hypotheses tend to set out the theory, nomenological validity is somewhat self-evident from your theoretical model and tends not to be explicitly reported in your research findings. The two remaining forms of validity, convergent and discriminant validity, may be tested in SEM and should be reported. Convergent validity is the extent to which an indicator variables align or converge on a specific latent construct. Convergence is demonstrated by items having a high proportion of variance in common, having a large commonality. Now, this can be judged from standardized regression estimates in AMOS by looking at output and searching for construct loadings and average variance extracted. Discriminant validity captures the extent to which a construct is truly distinct from other constructs. To assess discriminant validity, we compare AVE estimates with the corresponding squared interconstruct correlation estimates. Discriminant validity is attained when the respective AVEs are larger than correlations. If they are, you conclude that the indicator variables have more in common with one another and the latent construct than they have with other constructs. To evaluate discriminant validity, we first calculate interconstruct correlations from the output of correlation which can be found in AMOS model estimates. You copy correlation values from the output and square them. You then compare those squared correlations with AVE values. If the value is higher, like here in the case of our 5-construct SEM model and performance, then you are in the clear. If they are not, then you have a problem with discriminant validity. Now, such problem may relate to your items loading on other constructs, and you can go to modification indices to check that. You search for paths that link from a construct to an item that should not be associated with the construct. If you find such paths and the modification index is high, you may need to delete the item. To summarize, in this tutorial we have considered 4 types of construct validity and discussed how validity may be demonstrated in your research. This session concludes our treatment of measurement quality. In the next tutorial, we will look into the thorny issue of model refinement and respecification. See you then. Bye.